So Mark primarily works in the water resources area, which includes stormwater management, drain solutions, storage ponds, wetland restoration, hydraulic modeling, environmental permitting and review, and flood services. While water resources engineering is very broad, he works on projects related more specifically to wetlands, rivers, lakes, ditches, and ponds. Some of his daily tasks include project management, client interaction, design of stormwater infrastructure, and public hearings with government units and private landowners. And I'm going to go ahead and turn it over to you, Mark.
All right, thank you. I'm going to pull up my screen here. And then present. Well, thank you. Thanks for having me. My name is Mark Origer. I'm a civil engineer. I actually work for a consulting engineering group called ISG. We're located in 4 different states: Minnesota, Wisconsin, Iowa, and South Dakota. We serve several different markets, including energy, food and industrial, mining, public works, and water. And I work in our water industry, working on water resources related projects like Melissa had said. So just to kind of do more of a background, civil engineering is made up of 5 different disciplines. And as you look around, really civil engineering comes from civilian engineering. So projects that civil engineers design are directly related to civilians and the people somehow, some way. So a lot of people, when they think of civil engineers, they think of transportation, which is your roads and your bridges and how cars can move across the country. Other things are like structural, so buildings, bridges, vertical, anything that's structural, concrete, or steel related. Environmental, this one kind of has a little bit of a broad spectrum. Environmental for civil engineering is related to water, wastewater treatment facilities. It's also related to hazardous waste facilities and oil spills and things like that. Geotechnical, that's related to foundations and earthwork and making sure you have a proper foundation for a building, or looking at soil stabilities when you're looking at earthen banks and rivers and other high slope stabilities. And then water resources, which I deal with, that's basically how water either moves across the surface or underground and is connected to all of our rivers, lakes, and wetlands. And so when you look at powering the earth and how this might kind of tie in, every different discipline in some way deals with power. So you have structural, obviously building some power treatment facilities, or even structural when you have wind turbines or things like that. Environmental, looking at air quality, air things with turbines. Geotechnical, again, with your foundations. And water resources, looking a lot at how you can use hydroelectric power, or even use water reuse to cool down power plants or to provide power in different ways as well. So I'll focus a little bit on kind of myself and what I do water resources related here. And so I deal with primarily rural stormwater. And so projects that I have, and I'll go through a few different examples here, is I do a lot of wetland restoration design. So like the example that I'm showing here, I actually worked on a project where we abandoned some subsurface tile networks and restored an 80-acre lake. So this is a shallow lake, 2 to 3 feet deep, put in an outlet structure as shown at the bottom of the screen here, and really waited and let it flood up. This was constructed this year. I've actually worked on 5 different projects this summer that were built and still waiting for the rain to fill them up because it's been so dry. This is another example that was built about 8 years ago. This is one of the first projects that I worked on. And this put in a weir structure, which is a structure that holds back water. Also can be used in some cases for power generation, but in this case it was used for wetland levels. And we restored like a 45-acre lake here as well. Also in the rural areas, we do have a lot of excess stormwater that runs off of anything from wetlands or agricultural fields and roadways. And so we do design very large storage treatment ponds where we physically will dig out a big hole and then allow the water to sit and flood into it. So this is one example of a large one that I worked on. This one was built last year. So this is another stormwater pond that is about 10 acres in size, and you can kind of see around the whole perimeter, that's where we built up large dikes. and then diverted water, as shown on the right here, to flow into it. I do work on a lot of drainage systems, and in Minnesota and in Iowa, when you look at public rural drainage, it's similar to like your urban stormwater. So where there's stormwater networks and storm sewers underneath roads in town, we have those in the rural areas as well. I work on some of the open ditches and open channels, which are shown here. And what I work on with these projects is trying to repair them and maintain them so that they don't cause as much erosion and still have good conveyance for the hydraulics. With these rural areas, one thing that you always have to look at is flooding and erosion. So like on the left, when we're looking at designs, we want to make sure that we don't design a system that will overtop roadways. And then on the right, we're trying to eliminate scour. So this is just a design that I'm looking at correcting, where the past design was a really undersized culvert, and you can just see the large scour hole that is created from that. I do a lot with lakes and rivers too. More specifically on lakes, I look at watershed assessments, trying to figure out what pollutants stray into the lake, how does that impact the lake levels, lake algae, lake water quality. In this particular case here, this is showing an inlet into a lake that has had a large sediment delta build up over time, and trying to figure out what to do with that. And most of the time what you look at is where is that coming from and how can you stop it, because one thing that you don't want to do is clean this thing out and then have it occur back in a couple of years. So kind of look at a whole scale watershed and where impacts have on lakes. Rivers, I work on a lot of rivers too. So this is just showing an example of river flooding, making sure that the floodplains are connected and you know where that water is going. Sometimes you get too much water and then you have some pretty devastating flooding in some areas. What this picture is showing is just showing a river that's really meandering and the potential for potentially cutting through this high spot and making the river straight. So that's a natural process. We like to try to prolong that as much as possible just to reduce the amount of sediment and erosion that can be deposited downstream. I look at a lot of hydraulic structures. Like I said, I deal with a lot of water, a lot of runoff. So example is showing how water can move underneath roadways. So large box culvert structures. And then again, looking at weir structures, which other people can call like a dam, but this is looking at holding water at a specific level or a flow rate. Other hydraulic structures that I deal with are more of lake management. So this is showing a compound outlet structure on a lake that has internal boards that are shown in between these grates, where you can actually put boards through to change the water depth of that lake. So worked on a few projects related to that, restoring some of these lake structures and have them so they can be managed for different aquatic habitats. Some of the water quality things I work on, specifically looking at drainage areas when there's a lot of groundwater that is drained out. You do have the potential to have a lot of leaching of nitrates. So these are called wood chip bioreactors, where essentially you dig a big trench underground, fill it with wood chips, and allow the anaerobic conditions to absorb some of that nitrate from the drainage water. And the biggest thing with nitrate is its impacts on downstream drinking waters, especially for large municipalities that pull the drinking water in for their potable water distribution. Other water quality things I work on are alternative side inlets, and this is a case that we look at where we have a lot of erosion, and we try to design some of these structures to trap sediment before it goes into a river, lake, or even just an open channel. We do a lot of watershed planning, and so I mentioned this a little bit with some of our lakes, but we also do them for rivers. So state of Minnesota has a few different studies that are going out there, but looking at kind of a watershed-based approach where you look at the entire watershed, where are some of your major pollutant concerns, where is there a lot of runoff, where is there flooding, where is there a lot of contamination, and what can you do to prevent that from your source water. So for example, what does a watershed plan do to prevent algae blooms that's shown in this picture here? So we do a lot of that, more specifically targeting areas that you can reduce the pollution and ultimately reduce the amount of phosphorus and nitrates that drain into surface waters. I do get to work on a lot of different projects and use some pretty cool tools. So this is just showing an elevation tool that I get to use. When you look at this, it kind of identifies how water moves across the landscape. So this is an elevation LiDAR picture on the white that's showing kind of the top of the hill. And then on your blues and the greens, that's the bottom part of the hill. So I use maps like these just to figure out where some of the depressional areas are and how water can move across a watershed. Similarly, I get to use erosion tools. So I look at what type of soils they are, what their slopes are, and ultimately their potential for runoff. So this is what we use to target some practices to prevent sediment from going into downstream waterways. I also get to do a lot of really cool hydraulic modeling. So this is going to show an example of a project that I'm working on where we looked at essentially how a drainage system would impact a lake. And so I'll show you this video. We get to do a dynamic two-dimensional modeling, which shows the overland flow and how that drains downstream. So as you can see, I simulated a rainfall event here. The darker blues are showing maybe a couple inches of flooding, where the greens and the lighter blues are showing a couple feet of flooding. And so in this particular case, we looked at what a stormwater pond, which I showed a picture of earlier, can do to prevent flooding on the downstream lake. So we do a lot of really complex hydraulic models, again, just trying to figure out how our stormwater infrastructure, wetlands, ponds have impacts on the lakes and the rivers downstream. And ultimately, you can use this for source water and figure out where you have water to use for power generation. And that's kind of the last thing that I wanted to end on here is powering the world. Civil engineers do a lot of different projects that work with power, specifically building power plants or working on wind turbines and solar farms and the development of solar fields. One thing maybe more specifically to the kind of line of work that I work on, I personally don't design many of these systems. They're very complex. But looking at hydraulic dam structures. So really what you do is use water to your advantage. Water comes with a lot of power, a lot of force, and ultimately creating hydroelectric dams where you create a large dam structure and allow water to move through at some rate or some path. And then you have essentially an underwater propeller that will spin with the force of the water. And it uses that to generate power into turbines. And then ultimately those turbines can distribute power out to the grid. So this is a very, very common thing that was done. And if you look way back to our first settlement days, this is where a lot of the mills and industries were created right along rivers to use the power from the water to use their fabrication and their facilities. So this is just kind of a schematic. This is just another example of what one looks like in real life. Obviously, when you do these type of structures, you do have a recreational value. You can see in the back where you can get, boats and other things can go out onto these waterways. But again, damming up the water, creating a different hydraulic jump through the structure, and ultimately using that dissipation from the water into power generation. And then my last thing to talk about, when you look at the power generation, keep in mind there could be other uses for that. So I had mentioned recreational uses, but also consider the distribution like Lake Mead. So this is the Hoover Dam, this is Lake Mead down by Las Vegas. And this is not only used for power, but it's really used for water distribution. So there's contracts all throughout the southwestern portion of the United States using this as a water source. And what we've seen in the last several years is a huge decline in the water levels, and ultimately that impacts how much water can get distributed out to the citizens using that for drinking water. So this picture is just showing how high the water levels used to be, and then you can see kind of in the background how much that they have went down. And depending on where you look at in time, these water levels in this lake have dropped between 20 and 60 feet over the last couple decades. And so it's really, really challenging to get the water to use when you have less rainfall, less snow melt, and ultimately less water capacity for individuals to use. So that's kind of my thoughts on power, distribution, and energy. And, with that, like I said, I work on a lot of water projects, so I don't necessarily build power plants or maybe have the same type of background as other engineers may have. But the first thing that came to mind with me is knowing the force of water and how you can use that to generate power. So with that, I can take any questions or we can keep moving.
All right, well, let's see, do we have any questions off the bat? Let me start with one here, Mark. Is what kind of tools do you use when surveying or assessing some of these waterways and stuff that you're going to work on?
Yeah, that's a great question. Just with the evolution of technology, I've been exposed to a lot of different tools in my short tenure here, but a lot of boots on the ground, even if it's just going on site and meeting with maybe some of the county reps or landowners and assessing just using your eyes and photos, but also we have technology like survey equipment. So we use satellites to power our survey equipment, so you can go around and have an elevation shot within a hundredth of a foot, and we use that for design. We also use drones, so the drones can get up in the air and you can get a lot better perspective on some of the water projects and how things move across. A lot of times the drone will pick up a lot of different things that you cannot see just with boots on the ground. And then with our drones, we also have an attachment on one of our bigger helicopter drones where we can actually survey and scan the landscape. So like in this example here, we could fly our helicopter drone across here and pick up elevation points on everything on these bluffs coming into the dam.
Thank you. If there's no other questions right now, oh, we do have another question. Can you talk a little bit about what level of education is needed to do the work that you do or to get a job as a civil engineer?
Right, so maybe I'll talk about 3 different levels that I've seen in my industry. The first one, which would be kind of more of the basic level, that would be getting like a 2-year technical degree. And what that allows you to do with civil engineering technology, they call it, it allows you to be a surveyor or be a draftsperson, where you don't necessarily get to do all of the high level design, but you really get to work on a lot of projects, drafting them up, making construction plans, doing surveying, or even just help building the project in the field. So that's kind of a 2-year degree on the civil tech. Civil engineering, that's what I have. That's a 4-year degree. And really kind of the difference is having the ability to design plans, sign plans. And in every state, you do have to have a license to sign plans because it comes with experience and really just kind of that accountability to know, when you sign plans, you know what you're designing, you know what you're building, and it holds the engineer responsible. And then you can get a master's degree. I suppose you get a doctorate too, but that's really looking more specific on one particular thing you want to design. I see a lot of master's degrees for like structural, when you're looking at reinforced concrete or bigger structures like that. That's where I see a lot of master's degree. In general, a 4-year civil engineering degree can get you a long ways to do this kind of work and other types of work that I outlined in those 5 disciplines. It is a pretty rigorous program. It's tough to get it done in 4 years, but it definitely is a fun career path that I chose because you can get outside and do a lot of things where other fields kind of have you pocketed inside and you don't have the ability to get out and about and look at things.